Hi guys, this is you guys' video on Algebra June 2024. I'm going to do all the questions here and try to get through them and make you guys understand how you solve them. Right, question 1, straight to it. Question 1 is asking telescoping, and I did a similar question to this on my telescoping video. So I'm going to try to rush through it. I saw a lot of you guys watch the telescoping video. So I'm going to assume if you're watching this video, you probably also watched the telescoping video. First thing is, you apply laws of exponents. We're trying to find my answer to this, evaluate. You apply the law of logs, sorry, not exponents, logs. If you have an exponent there, you can just take it to the front. So we can write this as sum from r equals 1 up to 99 of 2 log base 10 of r by r plus 1. Now, there's another law of logs. There's another law of logs that says if you are dividing two logarithms, if you're taking the log of something that's divided like this, you can basically write that as log base 10 of r minus log base 10 of r plus 1. And the reason why we apply this is because we need the minus for telescoping. Telescoping will always have a negative sign, always be subtracting things. Now, let's take this 2 to the front. We're going to get a 2, and then we're going to be looking for the sum, because you can take out a constant out of the summation sign. You can always take it up. Sum from r equals 1 up to 99. And the second thing I'm going to do is I'm going to distribute this summation sign to the two things. So I'm going to have sum of log base 10 of r minus sum up to 99 from r equals 1 of log base 10 of r plus 1. Okay, again, we did a similar problem to this. That's why I'm not going into detail so much. We get to this question. Now, we just need to write out the first few terms of this and the last few terms. First few terms of this and last few terms, and see what cancels out and what's left. So basically we have 2 at the front, right? And the 2 is multiplying into everything that we're going to have here. And what we're going to have here, let's write this guy. We're gonna have r, we are basically opening up this sum, this one. At r equals 1, we're gonna have log base 10 of 1. At r equals 2, we're going to have log base 10 of 2. R equals 3, log base 10 of 3. Plus dot dot dot, there's going to be a lot more. Now let's go to log base 10 of 98. And let's also include log base 10 of 99. Okay, so that's this guy. Starts from log base 10 of 1, and he ends at log base 10 of 99, where r is 99. That's where it ends. Let's go to the second one. We put a negative at the front because it's negative. We have to subtract that one. Now, you got open bracket. When r is 1, this becomes log base 10 of 2 when r is 1. When r is 2, this becomes log base 10 of 3. And then we got more. Plus, close to the end, you're going to have a log base 10 of 98. Plus a log base 10, 99. The last term of this guy, where r is 99. If you put r is 99 here, you get 100 as your answer, because 99 plus 1 is 100. So let's write that last term, log base 10 of 100. Right, so this is what we have for this guy. Now, what you see is, you got the 2 into, you have this log base 10 of 1. There's nothing that's another log base 10 of 1 here. So you get log base 10 of 1 plus we got a log base 10 of 2. We have this negative log base 10 of 2 as well here. So you can just write that as negative log base 10 of 2 is going to subtract from this guy. So basically you're going to cancel out this guy and this guy. Also, this log base 10 of 3 is the same as this guy, but it's negative for here, log base 10 of 3. So this log base 10 of 3 is basically going to cancel with this log base 10 of 3 because they have different signs. Then you're going to have more. Now let's go to the end. By the end, we're going to have a log base 10 of 98 minus a log base 10 98. That 98 and the negative 98. 99 also going to cancel. Log base 10 of 99 minus log base 10 of 99. Now, this log base 10 of 100 though, it's not going to cancel with anything. So we keep that. What are we left with? If all of the middle terms, because even the terms that follow here, they're all going to cancel out. They're going to follow the same pattern. They're going to cancel out all in the middle. And you're going to end up with the first one and the last one. Sort of like a telescope. You know, when a telescope, you like fold it and then you end up with the beginning and the end. The middle parts disappear. That's essentially what we're doing with telescoping. You end up with the 2 at the front. You have a log base 10 of 1 minus, this should be minus, sorry, because of that sign, minus log base 10 of 100. That's 2 into, this is 0, because what is this asking? It's essentially asking, what power do we have to raise 10 to get a 1? Anything to the power of 0 is a 1. So that power is 0 minus, this is asking what power do we have to raise 10 to get 100? That's 2. So we have a minus 4 as our final answer. Right, let's go to the next question. This is question 2. Question 2 is asking us to find the sum to infinity of this guy. And they told us that k is greater than 2, but they're not telling us the value of k. So you might have to find the value of the sum to infinity in terms of k. Now let's look at this. Moving from here to here, you just multiply by 1 over k minus 1. Moving from here to here, just multiply by 1 over k minus 1 again. You see, so to every next term, you just multiply by 1 over k minus 1. So that means this is a geometric sequence. Geometric sequence. And for that geometric sequence, you have a, the first term, as 1 over k minus 1. If you want to do it, yeah, we have that. And then there's r for the geometric sequence. If you want to do it the long way, you can say this guy divided by this guy, and then confirm this guy divided by this guy. But you can just see it if you look at it. Like, if we have this, and we multiply by it, that's how we get the squared. If we multiply by the same thing again, we get the cubed. So we are multiplying by the same thing. You just see it by the increasing powers. So we do know that our r is equal to 1 over k minus 1. But you can do it the hard way if you like. The long way, not hard. Okay, we know our geometric series has these properties. Has a is that and r is that. And we want the sum to infinity. So we can simply find the sum to infinity as a over 1 minus r. That's a formula. You learned it in high school. Keep it in mind. Always remember it. So to find the sum to infinity, we know our a. We know our a is 1 over k minus 1 all over 1 minus 1 over k minus 1, right? I'm gonna change this division line to be that division sign. So I'm gonna change it to be like this. And then what's here, I'm going to find the lowest common denominator, which is gonna be k minus 1. And if I do that, I have to multiply this guy to the 1, and it gives me a k minus 1 minus 1. Right, so for this step, just use whatever method you know to find the lowest common denominator for fractions. Now I have 1 over k minus 1. Change the sign to a multiplication. You get a k minus 1 all over, because you have to switch it upside down now. This is going to be k minus 2 on the bottom now, because we switched it upside down. This k minus 1 is going to cancel that k minus 1. You don't have to draw the scratching lines. I'm just doing it so you guys see. You end up with a 1 over k minus 2. That's your sum. But I forgot to do one thing. To confirm if the sum to infinity exists, but because before you even find your answer, you have to check if the sum to infinity does exist. The sum to infinity for a geometric series can only exist, or can only be definite. Can only be definite if it converges. So we had to determine if this converges. So let's check if it converges. I'm just gonna do it with you guys, but I should write it because I'm training you guys for a test. So we're checking if this is converging. They said k is greater than 2. So they said k is greater than 2. If k is greater than 2, that means r, this is r, that means k minus 1, right? That means k minus 1 is going to be greater than 1, basically. You can just subtract 1 from both sides. K minus 1 is going to be greater than 1. So the denominator here is larger than 1, is larger than the numerator. The denominator is larger than the numerator. If the denominator is larger than the numerator, that makes it a fraction, a real fraction. And if it's a proper fraction, that means r, or the absolute value of r, is less than 1. This has to be less than 1 if the denominator is greater than the numerator. Less than, the absolute value of r is less than 1. Okay, so you can say therefore Sn converges. Right, so like this was us confirming if the series converges. Why does it converge? Because the denominator is larger than the numerator. If the denominator is larger than the numerator, that means this value is less than 1, because it's a piece of 1. Okay, that was all for this question, I think. Let me confirm. Yeah, let's go on to the next one. Okay, right after series, we go to binomial theorem. This is topics on binomial theorem and factorials. They say use this identity and this identity to prove this identity. Let's see how we can do that. If they give you what to use, ideally try to stick to that as much as possible. Stick to that, in fact, because that's probably how they prepared on the memo. So even if you have your own way, you want to use the way that's in the memo, just in case, like, you know, your mark is in a bad mood or something. I don't know who marks our papers. Okay, your papers. Let's look at this now. I'm going to start with the left-hand side. I'm going to start with n choose 0. I'm going to open that up, do it completely, get to an answer. And then I'm going to open this up, do it completely, get to an answer. Because I feel like that's super easy to do. There are other ways, there are the logical ways to just do it directly, and it's only 3 marks, so probably that's also fine. And choose 0. Let's apply this. You take the one at the top, you put it at the top again of the fraction, and factorial. This is the one factorial. Divided by, you take the one at the bottom and put it as a factorial there. So here I have to take 0 and put it as a factorial. Now I say n minus r, the top minus the bottom, factorial. The top minus the bottom, factorial. N minus 0, factorial. Okay. 0 factorial, they showed us it's 1. So this is just 1. So we have n factorial at the top over the 1 doesn't really matter because it's multiplying into the whole thing. So we basically have n factorial that we're left with on the denominator. These cancel out, they give you a 1. Now let's look at the other one and see if it also gives us a 1. You got n, choose n. That's n factorial over n factorial into n minus n factorial. As you can see, this is already n factorial over, this becomes a 0. So that's 0 factorial, n factorial. You see something? This is already the same as this, because the minus 0 doesn't really matter. So in a sense, you can prove it differently. I just really wanted to use the 0 factorial. And if you go directly from this to this, you don't get to use the 0 factorial equals to 1. Now this n cancels that one. This becomes a 1. Basically, the final answer is 1. Which means, therefore, n choose 0 is equal to n choose n, because they're both equal to 1. That's all for this question. Let's go to B. This was A. That was A. Let's go to B now. So now we have to find the coefficient of x squared, y to the 5th, in the expansion of this difference. Now, they said on the question, without expanding, you have to find the coefficient. So that means, although you can open it up and find all the terms, all the 6 terms of this expansion, you don't, because the instruction said without expanding. Now we know that the binomial theorem says, so it says x plus y to the n equals sum up to n from, what alphabets do you use? I'm going to use R. Oh yeah, they use R. From R equals 1 R is 0 of n choose R x to the n minus R y to the R. Okay, so basically you're trying to, this is the binomial expansion of something that has an x plus y. I'm just saying the general rule here, not specifically applying it to this question. Just a reminder. Okay, however, given that this is the expansion, a general term can be given by n choose R x to the n minus R y to the R. Because remember, this is a sum, which means you have the first term where R is 1, it's exactly this thing, but then R will be 1. Then the second term is exactly this thing, but R is 2. Next term, it's this thing, but R is 3, and so on. So Tina, I mean us, we can use this, we can use this, right? For a general term. We haven't applied it in this question, I'm just saying. A general term is given by this. So some will call this T of R plus 1. But this is a general term. Say T of plus R plus 1 is equal to this. This is basically what we're going to use. So let's try to apply to the question specifically. What's our n on this question? The exponent on the outside, it's 6. So a general term for this specific question will be 6, choose R, of, let's check our x. Is it just x? No, it's actually negative x squared. So let's write that as negative x squared, right? All to the power of n minus r. I'm going to use 6 minus r because we already know our n is 6. Then we go to the y. The y is just a y on the question. So that's y to the r. Now, this is a general term. This is a general term on our sequence with some random power. We want the term that has y to the power of 5. And I'm strategically choosing y because y only has an r. It doesn't have like a 6 minus r. So if I choose y, I can just say r equals 5. It's straightforward. For someone else who chooses this, they would have to say 2 times 6 times r and like figure stuff out. Don't confuse yourself. Mathematicians are supposed to be lazy. To take the lowest root possible. So for y to the 5th, r equals 5. Okay? That means our r is equal to 5. So we just need to substitute an r that's equal to 5 here so that we get our coefficient. We have a 6, choose 5 of negative x squared. 6 minus 5, y to the 5th. So we have our y to the 5th now. We just need to confirm if this ends up being an x squared. If it doesn't, that means something is wrong with our formulation. We have a 6 choose 5. Our 6 choose 5 using that formula from the other page for the other question we just did. It's a 6 factorial over 5 factorial into 6 minus 5 factorial. If you're looking at the question paper on another screen, it's just above on the top question. This becomes negative x squared. The power is 1, so no big deal. No big deal. We can just omit it. Y to the 5th. So y has a good exponent. X has a good exponent. This negative, it's part of the coefficient. So take it to the coefficient. Let me put implies here. Yeah. Now, that's 6 factorial. 6 factorial is 6 times 5 times 4 times so on. But it's basically 6 times 5 factorial. Over, let's put the negative sign, that one. 5 factorial. This becomes a 1. So that's just 1 factorial. X squared y to the 5th. So these guys are fine. These cancel out. We just get a negative 6. That's our final answer for the coefficient. Because our answer was looking for the coefficient. So therefore, coefficient of x squared y to the 5th is negative 6. That's the answer. That's how you do that one. Okay, let's go to the next. Question 4, induction. They want us to use induction to prove that this is true for all values of n that are natural numbers. So whenever you do induction, you have 3 steps. First is base case. Next is inductive hypothesis. And finally, it's inductive step. Then at the end, you should conclude. Just do these 3 phases, and then your statement will be proven. So let's do the base case. For the base case, it's the lowest natural number value of n. It's the lowest natural number value of n. Natural numbers are 1, 2, 3, 4, and so on. So the smallest natural number is 1. And 1 is included here because they didn't provide a restriction for n. So the base case, in this case, should be a wrapper. In this case, is 1. N is 1. So, left-hand side becomes a 3, and the right-hand side becomes a 3. Hence, base case holds, right? So if you put a 1 here and you put a 1 here, both sides become a 3. And if both sides become a 3, that means this is true, because 3 is equal to 3. So this inequality is correct because it said greater than or equal to. So it's accounting for the or equal to part, because the equal to part, they are equal. So that means the base case holds. Okay, now we go to the inductive hypothesis. For the inductive hypothesis, you assume that the statement is true for some integer value k. Right, so you are fixing. This was a free variable n, so this was saying for all values of n. Now you're assuming this is true for a specific value that is k, but we're not writing what that value is. We're leaving it free, but it's a specific value where k is an element of n is an element of natural numbers. So k is a number that is one of the numbers that are n. But since you're an engineer, you can just say k is an element of natural numbers. That'll be good. You can just say k is an element of natural numbers. But for math major guys, probably you might want to write this. Possibly. Not super sure. Let's go. Now the next step is we've assumed, so we have our inductive hypothesis. We go to our inductive step. For the inductive step, we want to prove this holds for the next integer value of k that is following k. For the next integer value of n that follows k, yeah. Right, to prove this is what we're going to do. We're going to start with the inductive hypothesis. 3 to the k is greater than or equal to 3k. We're going to start here. I'm just going to give you guys the steps. You can apply these steps to almost all of these, all questions that are like this. You can apply them. First step, just multiply by 3 both sides. Why 3? Because it's the base of the exponential function, of the exponential thing. I guess you can call it a function. So multiply by 3, the base of this guy. 3 into 3 to the k. 3 into 3k. What does this simplify to? Gives us a 3 to the k plus 1. That's what we want first. 3 to the k plus 1, which is that. And this is related to this, which it is greater than or equal to. That's going to be 9k. Okay, now what you're gonna do is you're gonna say 3 to the k plus 1 is greater than or equal to 3k. I'm taking out a 3k from the 9k. That means if I took it out, I have to have a 6k here. Basically, I broke up the 9 into a 3 and a 6. Because if I have 6k's and 3k's, if I add them back, they give me a 9k again. Now, I can say for sure that this is greater than 3k plus 3. I can say for certain. Why? Because if you compare this guy to this guy, they both have a 3k, so you can ignore the 3k's because they are equal. They just cancel out. That means if you want to compare which one is larger between these two guys, you have to compare the 6k and the 3. So 6k is definitely larger than 3 because k is like 1, 2, 3, 4. It's a number that is positive and it's an integer. So you always be multiplying 6 with a positive integer, which means this will always get bigger and bigger than 3, which doesn't change. And be careful, this is like straight up just greater than. You can put or equal to. I guess it's not technically wrong, but it's just greater than. Okay, next is the reason why I just randomly stated this. It wasn't random at all. I was trying to force it to give us something that's similar to this. Because this, if you open it up, if you multiply the 3 to the k and the 3 to the 1, you get a 3k plus 3. That's what I was trying to get here. So you can follow these steps with almost all of these questions that have the greater than or equal to sign. You will usually get the answers. The only time when you don't get the answers is if this is structured differently. So if it was 2 to the k and 2k, you can still use it. 5 to the k, 5k, still use it. Any like, even if it's like 5 and 6, yeah, or something, you can still use it. But then if it's squared or something, then a bit different steps have to be incorporated to get you the answer. But for now, this is fine. This is true. So therefore, I found it hard for students to understand why I can conclude now that 3 to the k plus 1 is therefore greater than this guy. So you can use this. You can draw sort of, I hope this is going to make it clear to you guys. Yeah, so 3 to the k plus 3. We are saying 3k plus 6k is greater than this guy. So this is 3k plus 6k. You see, it's taller than this guy, which is 3k plus 3. So he is bigger than him, right? That's what the first part is saying. He is taller than him. In fact, we can see it because this box is taller than this box. The next statement says, this guy is greater than this guy. So that means this guy has to be taller than him, right? This is him. So that means 3 to the k plus 1 has to be the tallest, or the one that is taller than him. Automatically, this guy has to be greater than this guy. There's no other way. If this guy is greater than this guy, and this guy is greater than this guy, then this guy absolutely has to be greater than him. So we can then come to the conclusion. Don't draw these. I hope you guys get that. That's for demonstration. Greater than 3k plus 3. Right? And then we have 3 to the k plus 1 is greater than 3 into k plus 1. We have proven our thingy, this thing. It's proven now. Although ours doesn't have an or equal to sign, it doesn't really need to that much. I'm gonna show you why now. The reason why we don't need to have an or equal to sign here is because the only place where these guys will be equal is when n is equal to 1. When n is equal to 1, we get a 3, we get a 3. So, n is equal to 1, these guys can be equal. But as soon as n is equal to 2, this guy becomes a 6, this guy becomes a 9. They will no longer be equal. This guy will grow way too quickly, and this guy will grow slower. Therefore, they will never be equal. So, the only case where they are equal is when n is equal to 1. And this is k plus 1. So, if k is any number, k can be 1. That's the only time when they can be equal. But if I'm saying k plus 1, that means I'm already excluding 1. Because k can only start at 1 and go up. So that can be 1 plus 1, which is going to be 2. So this automatically starts at 2 and goes up. If you don't get that, you're an engineer. You don't have to stress too much. You just need to know how to solve problems. Realistically, if you guys want to get great marks, you just need to know how to solve problems and solve problems, a lot of problems, and you'll pass your test. You don't need that deep understanding of stuff. It's honestly a waste of time. Probably your teachers are going to hate me for saying that. So we have this. We can just say now, hence, I'm actually lazy. Base, inductive step holds, and 3 to the n is greater than or equal to 3n for all integer values of n. Yeah, that's the entirety of that question. Inductive hypotheses and like bases and stuff. Let's go to the next one. Question 5. They gave us this equation. Canonical forms. They want us to first write this in canonical form and then substitute u and v for the canonical form. To do that, you first complete the square for both the y and x. To complete the square, you should not have a coefficient for for the leading term. So let's factor out the 4 from the y, get a y squared. Because we have to complete the square for the y's, we also have to factor out the 4 from the 8y. That gives us a minus 2y. Here, we should not have the negative 3. Let's factor it out. You get x squared. Since I factored a negative sign, this should change in sign. It should be negative 4x equals 20. Now the next step is you're completing the square. You should add half the coefficient of the middle term squared. So that's 4 into y squared minus 2y plus 1 minus 1, right? This is the completed square this side. Minus 3 into x squared minus 4x plus 4 minus 4. This is a completed square equals 20. Let's remove all the bits that are not part of the square. So to take this outside of the bracket, you have to multiply it by the 4. That means we have 4 into y squared minus 2y plus 1, which is the perfect square. And then taking this out, we multiply it by 4, we get a minus 4. Minus 3 into x squared minus 4x plus 4. Taking this out, it must be multiplied with a negative 3. That gives us a positive 12. equals 20. Next is we have 4 into, this factors out to be x minus 1 or squared. This minus 3 factors out to be x minus 2 or squared. 12 minus 4, that gives us positive 8 equal to 20. Now we did our first step, about to finish. 4 into x minus 1 all squared minus 3 x minus 2 all squared equals the 8 to the other side, so we unify the constant. It becomes a 12, right? Yeah. Right, that's the first step. Just completed the squares. Oh wait, should be y here. It's these are y's, right? Okay, that's y. Next step is divide by the constant if it is not 1. Divide by the constant on the other side if it is not 1. We should have a 1 here. There should be 2 completed squares and a 1 on the other side. Whether you're looking for a circle or any like canonical form, aside from I think a parabola and yeah, I forget these things. But in this case, divide by 12. Most of the time we divide by that. Now we're gonna have a 1 there. But what's gonna happen with these guys? The 4 here is gonna cancel a 4 here, which means we're gonna end up with a 3 only. So that means we have y minus 1 squared over 3 minus, here the 3 is going to be cancelled. We're going to end up with a 4 only on the denominator, minus 2 all squared over 4 equals 1. Right, we've done the second step, which was dividing by that constant. The next step is just finding your u and your v, right? Your u is going to be this guy and your v is going to be this guy. That's going to be u squared over 3 minus v squared over 4 is equal to 1. Then the question also said, basically you've answered the question. It said find basically this equation in this format. The next part of the equation says find or state what u is equal to and what v is equal to. Find those equations. U is y minus 1. V is x minus 2. Okay, essentially that's the first question. The next question, if I remember correctly, yeah, I'm gonna do it from memory actually because it's, I think it was just saying state what type of canonical form this is. Because we have something squared, and a negative sign, and a 1, this has to be a hyperbola. Why? Because it's the difference of 2 squares that's equal to 1. A difference of 2 squares that's equal to 1 is a hyperbola, right? Usually it's written as u squared over a squared minus v squared over b squared equals 1. This is a squared, this is b squared. Difference of 2 squares that's equal to 1, that's hyperbola. If this was positive, that would be an ellipse. In this case, it's a hyperbola. Let's go on to the final question.